Here for a seminar. It's great to have a joint seminar as well between us at SGRI and those at the CPC, and we're delighted today to have a seminar from Professor James Raymer. James is a professor of demography at the Australian National University, interested particularly in demographical studies, of course, with a keen interest in looking at migration patterns, particularly how they affect the changes in population. And today he's going to be talking to us about modelling the age and sex patterns of net international migration. So, hey James.
Great, thank you, Ewan. Yeah, hi everyone. Yeah, this is how do I introduce this? This has been a fun project. We're working with the United Nations on trying to come up with a model, a set of profiles for net international migration. Now, for those of you who know me, not a big fan of net migration, and when they first can't do this work, you shouldn't do it this way, but they sold me on the idea, and it's actually been it was a small project, but it's been a lot of fun, and I'm continuing to work on it, so happy to go through with you. But first, I've got a few introductory slides for the non-migration people in the room. So first of all, most countries in the world do not gather statistics on migration flows. Okay, we don't know much at all about migration, especially outside Europe, where people are going to, where they're coming, what the numbers are, how they're influencing change, and all that. And even when countries report statistics on migration flows, they're not hardly ever comparable, measured differently. They don't capture everybody in the population that you want, or they're not clearly defined. You might only have like foreign workers. You don't really know what that means. Is that children? That thing's making noises. Is that okay?
Yeah. Turn the volume down. I can turn the volume back up when we have questions at the end.
All right. But that said, if we want to do any type of demographic analysis, if we want to predict populations or do population projections, we can't ignore migration. We have to somehow overcome this huge obstacle of no data or really inadequate data, so that we can do our demographic analysis. And I'm going to be focusing primarily on age and sex patterns today. They're critical for understanding the patterns, the motivations of the migrants. Everything differs by age or sex, and as inputs into demographic accounting models, which are always age and sex specific. Another issue, and this is something that goes a lot of work that I do, is trying to overcome this issue, is whenever we think about migration, it's often done in a silo that's separate from the population stocks that they're influencing. So often migration are analyzed by themselves, and they're predicted by themselves, or they're only looked at from a single country perspective. So you might only look at who's coming to the UK or who's leaving the UK. And you're not always thinking about where migrants are going to. But migration is naturally a process of moving from one place to another. So a lot of my work is trying to reconcile this, trying to account for this in my thinking and my modeling. Because if you don't bring together the migration flows and population stocks, it results in partial understandings and consistent measurements. And I think a lot of the problems that we have today are tied to this, especially from a statistical perspective. And migration is different from other types of statistics because it really is a relationship between two places or two countries. So a lot of the work that I've been doing is trying to overcome these problems by creating these integrated data systems, analytical strategies, where my kind of fundamental aspects that I work on is trying to combine, share information, to try to gather as much information as you can. And I did a lot of that work here at Southampton many years ago. So how can you combine data to produce better estimates of migration? Always looking at it from an origin destination perspective and placing it in a demographic account. That's the flows and stocks model. Because that places migration in the context of overall population change. If your numbers are too small or too big, you'll notice it when you put it into a demographic account. Further, by being able to track populations and entries over time, we can better understand the effects of migration on demographic change, society, economy, political systems, and so on. So I've been pushing this agenda for a long time, and those of you who know me, this will be familiar. And lastly, the other message I'm always saying is don't do net migration. Avoid it at all possible. It's unpredictable. So net migration is the difference between in and out. So it's the difference in flows. So it's unpredictable because the flow can increase because more people are coming in or fewer people are leaving, right? It's unexplainable for the same reasons. So we don't know if the flow has increased because more people have come in or fewer have left. And although I see this all the time as a policy instrument, it's not useful for policy. Migration policies can really only influence people coming into a country. They hardly ever can influence who's leaving. All right, so that, so, you know, we can restrict visas. Actually, even for inflows, we can't restrict everything. So citizens always have an automatic right of entry in almost every country I can think of. But they can restrict students or labor workers and those type of things. Okay, so that's a bit of background. Now coming to my project, to this project on net international migration. So with that background in mind, my first instinct to tell them was, well, you shouldn't model net migration. It's not possible. It's not predictable. But they were quite flexible in how I approached it, and they were what I originally wanted. They wanted was like a review of the literature, some methodological ideas, and ideally some solutions. So this work was commissioned by the UN Population Division, starting in 2022. We're actually still, well, I finished the project, but we're still communicating and working on it. I was in New York right before I came to Southampton. We worked a bit on this and improving the model. But for those of you who don't know, they have this World Population Prospects data set that does single year, single age population estimates going back to 1950 and projections going on to the end of the century, probably, or at least to 2050. Okay, so they include all countries in the world. But they've always struggled with the migration aspect. Okay, and the way they've done it in the past is they first estimate the net migration totals, and then they just aggregate it by age and sex. And they didn't want me to touch this stuff. They're happy with this, or their methods for doing the totals, they were fine with. And all I had to really focus my attention on was how you can distribute a net migration total by age and sex. What should it look like? Okay, and they need these as inputs into their demographic accounting models for both estimation and projection. The other thing that's kind of important in working with the UN, and especially this group and this work, is they need a method that's simple, that's transferable across a lot of different countries and situations. So, you know, you have countries like China, 1.4 billion, and then they've got these small Pacific Island countries with, you know, thousands of people. They needed to be able to use kind of readily available information. And so they wanted something, yeah, that they could easily apply and modify, and that they could explain to users. So that's what they're looking for. And I was attracted a little bit by that too. Okay, so for measuring net migration, the ideal situation is you would have flows of immigration and emigration, and you just subtract emigration from immigration to get your net migration. As I said on the second slide, we don't have this information. So what is often done in practice is you infer what the net migration is using a demographic accounting equation. That is, net migration is equal to population times t plus 1 minus the population times t minus verse plus this. Okay, and this demographic accounting, there is no other components of change. So long as all this information is true and accurate, then you will get your net migration. So it assumes your population birth and death data are accurate and complete. The reality is they're often not. What's happened, what you get from a net migration residual is a combination of net migration and any error that's in your population birth or death data. And to give you some illustrations, so this is some of the residual data that they had estimated. This is from the UN Population Division's methodology for doing residual estimation. And the red line is females and the blue line is males. And so they were getting residual estimates by age look like this, which is kind of all over the place. Didn't make a whole lot of sense. Like, why would you have why would net migration be very negative for these age groups, and for females close to 0 for these age groups, and then very negative, and then increasing? Why would males and females differ? Is that a real pattern of net migration, or is that a function of errors in the other population or birth estimate? Here's one from India. It's kind of all over the place. So it's hard to come up with a theoretical explanation for why net migration by age and sex would look like this. And there are even worse cases. Sometimes all the error, it was obvious that there was problems in the data because all the error would be in the first age group, which is a problem with the birth data, something like that. So they wanted something a little more. And what they would do historically, if they had a pattern like this, is they wouldn't use it. They would just throw it away, and they would take what's called a Rogers-Castro curve, which is basically what they would do is if you had a positive net migration, then all net migration would be positive across all age groups, but with some concentration, or most concentration in young adult age groups. I'll show you in a second. Okay, so, and I was actually surprised. I thought I would find some work on this, on kind of profiles of net migration by age and sex, because it's used in almost every local area or country has to do population estimates and projections, and a lot of them do rely on net migration, but there wasn't a whole lot of literature on profiles of net migration by age and sex. And the work that I did find was in the 1970s by Donald Pittenger. And even he did, which is kind of what I was thinking all the way, is you can't model net. And he came up with these age profiles of net migration, but they were based on empirical data looking at in and outflows. So that kind of justified, I'll show you on that in a second, but justified my thinking that there is no, I couldn't think of a systematic kind of what a net age sex profile should look like. And what I found in the literature is mostly concentrated on migration flows, not the net, like ins and outs. And there's lots of work done on this. If you look at people moving, not net differences, it's almost always a high concentration of young adults. The patterns, the shapes of the age patterns, sex patterns can be linked to populations at risk, life course factors, or causes of migration. Okay. So my review failed in some ways, but here's just an illustration of what your age patterns of net migration will look like under different assumptions. These are all hypothetical. So on the top one, so the red line you can think of as inflows, and the blue line you can think of as outflows. And the green line is your net pattern. So if in migration and out migration are exactly the same level across all ages, then net migration is 0 and a flat line. Okay, if we take the second example, if in migration is higher equally across all ages, then again you get a flat line, but it's above 0. If you have higher child migration, then you get a flat line except in the child years. If it's just higher in the young adult years, you get a flat line or bump. If you get more people leaving across young people and young adults, children and young adults, you get this shape. And you can even have a situation where the levels are the same, but the people coming in are younger than the people leaving. And so you get a positive peak and followed by a negative peak. And actually, I'll show you some data shortly, but this is the data that I would expect for a lot of countries internationally. Maybe more flipped the other way. So if you think about a country like China, which is stereotypical emigration country, a country that sends a lot of migrants. That's often thought, or India, or country. They're sending out a lot of migrants when they're young for education and so on. But but not all of them stay. Some of them, after they complete their education, will return. So you would expect, or I would expect, kind of a negative peak here to start with, but then some return migration that would be positive coming back. Or you have a temporary flow situation. So there was another motivating factor I should mention related to this is they were also, I had to look at countries in the oil producing countries, Global Cooperation Council countries. And there the populations are like 70, 80% migrants, overseas born, but they're all on temporary visas. Okay? Which means they can't stay and retire there. They can't. So they're only there for a few years. And their current net migration models, which would have maybe look something like this, so they'd be all positive, messed up their population accounting models because they kept growing the population and migrants would age into the population. But in reality, you had to have some mechanism for allowing people to come in when they're young, but having them also leave. And all of this constrained within this kind of net migration space. So there's some interesting challenges we worked on. Okay, so for the rest of the talk, we'll talk about the procedure, these are just simple ideas, but they can be improved upon, expanded on, and already we're starting to do that. So my strategy that I proposed was, let's not try to model net migration directly. Let's first try to model immigration and emigration. I believed I could do a better job of that than net migration to begin with, even though this is two things rather than one. And then if that's true, then we'll just take the difference to get our estimate of net migration. And the model I came up with is just a simple, it's a decomposition, multiplicative model, another thing that I like doing. So what I'm interested in is this n hat xy, which is my net migration by age and sex. And what I'm doing is I'm breaking it up into an inflow and an outflow, or immigration and emigration. And what I'm going to do is I want to model three things for each direction. An overall level, total number of people coming in or leaving. And then I'm going to proportion that out by age and by sex. And actually, my age profiles are going to be sex specific. So actually, I need two age profiles for this and two age profiles for the immigration and an overall proportion of line. Okay, now, none of this is observed, so I have to come up with a way to model each one of these. And the trick, or the thing that I thought might work and actually worked really well, was my level. So the immigration, emigration, there's no data on this. How can I approximate it? Well, I knew from my other work that the size of migration, the level of migration is highly correlated with the population size. So basically, bigger countries send more migrants than smaller countries. The other thing I knew that I wanted to incorporate in my estimates is inflows and outflows are highly correlated. You often see that when you look at migration. They don't have to be equal, but they're highly correlated. Okay, so what I did is I basically came up with a single rate of migration, which is unknown. And I'm going to multiply, that's going to be the same for inflows and outflows. I'm going to multiply it by the population size, and then I'm going to constrain it. The other trick is I'm assuming net migration totals are true. So I'm going to constrain it by the net migration. And the way I do it is for inflows, I'm going to add half of the net migration, and for outflows, I'm going to subtract. Of course, if net migration is negative, this will end up being negative, and that will be positive. And then for M, I wasn't sure what that would be, but I knew after looking at a lot of migration flow data at the international level, I knew it was going to be small. So I had this rough idea in my head, and I'm sure it's from the work I did on European migration, that, or maybe even the UK, that any given year, I would expect about half of the population, 0.5% of the population to migrate internationally. That was kind of my starting point. Turns out that this doesn't really matter. So, I mean, it matters to some extent, but it doesn't matter a whole lot. The key thing is you don't want to get negative Like it's got to be big enough that you don't get any negative results from this simple mathematical. You can't have a negative number here with the emigration, and you can get that if this isn't big enough. Okay, so, because I'm not really interested in predicting the I and the E's, I just need something that's going to allow me to do a good job in estimating the net by age and sex. So that was kind of a trick that as you'll see, worked well. And the other thing, of course, I'm assuming that the ends, the blue total net migration is true, which in all likelihood, especially with the UN data, not. At the time, it wasn't my problem. That's another problem to solve later on. Okay, so that gave us the levels of in and out, or immigration, emigration. And then the other things I needed were these proportions, 4 different age profiles, and 2 kind of simple proportions by sex, male, female. So I came up with this method. I had to prove that it worked, so I got some empirical data. I used Sweden's data. This is stuff I just had sitting on my computer. Sweden's gotten quite old. I could have updated that, but too lazy to do it. And what I did is I just looked at this kind of time series data, and I just, for my kind of proof of concept, I just took average proportions, observed proportions, to see how well they would predict changes over time. And so it turns out for Sweden, my overall rate was 0.007, so about 0.7%, which wasn't too far off from my 0.5%. Migration flows in both directions were slightly more male, so 52% of immigration were males and 54% of immigration was males. And then I also had data on South Korea here. The overall rate was much higher, 1.2%, but also more males both coming and going and about the same proportions. This isn't what I modeled. This is the observed net migration totals over time for Sweden. Actually, we'll go back. I had data going back, but I constrained it later on, just to a more recent period. But you can see it fluctuates, net migration totals. And if you're trying to predict that, that could be pretty hard. But again, where the red line's females, blue line's males, largely working together over time. I'm just going to be looking at this period here. But I'm going to take those totals as given. The age sex profiles, these are my 4 profiles I used as inputs. They're pretty similar for males and females for both immigration and emigration. Some small subtle differences. You see females are slightly younger. Males have this, for immigration, have this strange peak. Anybody know what that is? It actually started around year 2000 and got bigger and bigger and bigger to about, I think, around 2008-9. Anyway, this was unaccompanied minors seeking asylum. I was able to find out because I did a time series modeling, time series forecast model with ARC. And this totally messed up our whole model because they had this strange peak that we didn't expect. It was only happening for males, not females. And so it was a strategy to send young males before they're 18 to Sweden to seek asylum so that then more relatives could come in later on. Okay, that's that. And all right, you have to remember that equation, but I put those proportions I just showed you into the equation. And then these are all averages, right? So I'm keeping them fixed over time. And these are what we have here. The red line is the observed data. The blue line is my estimated using that simple kind of multiplicative differencing model, whatever you want to call it. And what was great is it, well, looked near perfect to me. Here, this is, sorry, you probably can't read it, 2007. 2009, 2011, males on top, females on the bottom. I'm just extracting, I actually did all. I'm not sure if that was a question or just people talking. Okay, but you can see it's capturing even the little peaks for males and not for females, just because of different ones. It's capturing, because I'm trying to the total, the observed net, it's going to capture the level anyway, but it's also capturing the age and sex profiles very well. But for South Korea, same thing. Here's the observed net migration totals. We're seeing more variation between males and females in over time, but it's bouncing all over the place. The age sex profiles also look a bit different, but similarly, females were younger than males, a lot more sharper peak and higher in terms of proportions. The males have a slightly broader pattern. Okay, and I plugged those same thing, fixed average proportions into the model, into that model, and I compared them to the observed data, which is the orange in this case. Blue is the estimated. It wasn't quite as close as Sweden, but from my perspective, it was really good. I mean, it's capturing these double peaks, which is strange. It's even capturing changes in the peaks over time. Here, it didn't do so well. But overall, I thought, I mean, these things would be hard to predict otherwise. Okay, so that was my proof of concept. So I don't have a clock, so I don't know what I'm doing. Can you give me a 10-minute warning or 5-minute? Yeah. Okay, so now that was my using empirical data. Now we had to translate the ideas to a situation where we don't have any observed data. And so here we're again interested in all countries in the UN World Population Prospects database. And we focused just on the estimation period, 1950 to 2022. And from that data set, we had readily available population totals and net migration totals. We don't, these things, well, to get the total immigration and emigration levels, just to start off with, we started off with just this simple assumption of 0.5%. This is an adjustable parameter, and at the end I'll tell you how we've adjusted that. That doesn't work in all cases. Sometimes it's too low. Sometimes, yeah, it's a problem when it's too low rather than too high. And then for proportions of immigration and emigration, this is, we use Guy Abel, who was a student and researcher from here originally, who's done this stock to flow estimates, and he's done it by sex. So we were able to get proportion, origin destination proportions. Well, actually, we just took the margins proportions from and to each country by sex, but we averaged those against an assumption where they were 0, because some of his estimates had like 90 or 100% of all migrants being male or female. That, like, it was, sometimes it was too extreme, so we kind of dampened it towards 0 as an assumption. Okay, what we didn't have was the age sex profiles. Okay, so that first part was kind of easy. We could grab data pretty easily, and then how do we come up with age sex patterns for all countries in the world whilst trying to keep it simple? And this is all programmed in R, but in a way that allows the user to select things without giving them, 100 different options. So I did some digging, and also looking at empirical data, but it seems like there's 2 types of shapes. And actually, I found an old UN manual that was actually for internal migration, but it identified different shapes. And I plucked out 2 of those. One was the Western standard. This is their terminology. I don't know if it's appropriate anymore. But basically what it meant, it was a migration age profile that had a pretty broad labor force curve with children migrating. No retirees, but focus on labor force. And then the low dependency standard was a migration shape that was just concentrated in the labor force age groups. Okay, so let me talk about a second. I'll show you the profiles in a second. I knew looking at, like you can see from Sweden, actually I didn't show this, but if you look at data, I also thought, well, sometimes our age profiles are younger depending on the direction. So the assumption here is if a country is receiving a lot of migrants, that means the migrants coming in are probably younger on average than those that are leaving. Okay. The idea is that, yeah, people migrate when they're young, they go for education, and then a few years they return home. And when they return home, they're older. Same thing with the sending country. Emigration would be younger than immigration. And then we allowed for options by sex, so whether you expect the age profile to be slightly younger if they're males or slightly younger for females. And the two examples I showed you is the females that were younger, but you may not know, and you could have the same. So the age profiles we used, at least in the first iteration, look like this. This is for a receiving country profile. It has both the Western standard and the low dependency kind of standard. The Western standard has the main difference is has this big downward slope of children migrating, whereas the low dependency is much lower and then it's more concentrated on the adult age groups. The Western standard also is a bit older in terms of its age profile. What else can I say? And then the way we shifted is we just took a model migration schedule. I don't think I need to explain. It's not important for me to explain. But there's parameters. These are all parameterized models, and there's one parameter that adjusts the location of the peak. And so I just shifted it one way or the other. Okay. And what we did is we developed some R code, and we allowed the user to pick the country for this, say China. What would you expect? You expect it to be a sending country. Would you expect males to be younger, females? If you don't know, you might hit neutral. And would you expect low dependency or Western standard? So for China, and I think we used the low. I didn't write it down here, but I think we used low dependency schedule, receiving or sending country, and then we plugged in all that other information, the net migration totals, they were available from the UN, the proportions by sex. We got Abel's estimates, and these are the results that we got. The blue line is males, red line is females. And what I like is you do see some differentiation for females than males. Males especially have higher peaks coming back. Females actually have slightly more leaving. This, I mean, we didn't use Australia. This actually fits well with the Australia pattern of migration from China to Australia. More females come in, but more males leave. Anyway, so that was nice. And then just another example is the Philippines. Here we got a lot more differentiation, a wider pattern over time. Sorry, this is 2007 to 2022. I'm just taking a snapshot from the estimates that actually go all the way back to 1950. But we're seeing, in some cases, it's all constant, it's negative, and it's all concentrated on all ages are negative. But in 2015, for some reason, you started getting some positive patterns just for females, which is different than China, and so on. So you're getting different shapes over time, depending on the levels and the input parameters. I'm quite happy with this work. I mean, it's a very simple method. Anybody could do. I could do on a spreadsheet, but they can do it. We were able to hand over the code to them, and they can get to work right away on it. It's a simple method for coming up with age and sex profiles of an international migration. May not be perfect, but it was better than what they were doing before. The model is flexible. All those things can be adjusted. You can have more age profiles if you want, or assumptions. But you can easily apply it to any country. And the next steps for this project, I don't know if I've gone too fast or if I'm on time.
10 minutes.
Okay, great. Is we're well, I was in New York, and actually it didn't work perfectly in all cases. So they have their residual estimates that they've got from the demographic accounting equation. Now, a lot of it's usually pretty good for countries that collect good data, hence you probably don't need this method. But what they were finding is sometimes our age pattern assumptions, where the peak wasn't lined up with where the net residuals were lined up in those young adult age groups. And also sometimes the M wasn't working well. So we played around some optimization techniques and ways to use the observed residuals, but constrained to kind of young adult age groups to see if that could inform the model better. So we could estimate the M from the residual information. And same thing with where the position of the peaks should be, the model schedule peaks. And what they told me is they're happy with it. They're applying it now to do their next round of population projections. So it's replacing their previous method for the projections, but they haven't applied it to the estimates yet. The estimates is more complicated because they've got to make things match between one census and another. But that's going to be the next stage of work after they produce the projections, is to see how the new method works in kind of doing demographic estimation. Another extension, which is I'm working on this at the moment, is I was in Washington. I was explaining the method like I am here to colleagues there at the University of Washington. They have a population center. And Adrian Raftery, a lot of you know who that is, and Hannah I forgot how to say her name. Sorry. They were having a similar problem. We were talking about their work, and they needed to do population projections for counties in the state of Washington. It's a small area population projection. And they had net migration by age and sex, but they were struggling to forecast it. And so we played around with this with a kind of similar method. I said, well, let's try to model the ins and outs. Data was slightly different. So in this case, the ins and the I's and the O's are the same idea. You predict the levels, but how we decompose it was different. So here the M is actually one model schedule. Actually, it doesn't really matter what this is. They're just the same on both sides. And these R's were using the observed net migration to inform that standard shape. And they applied a Bayesian method using this. So actually, where they are able to predict the model schedule here. So they didn't have this. This was my simple method. But that was pretty exciting. They were able to actually predict the model schedule, and it produced really good estimates and better population estimates. Better net migration forecasts. And then my idea was to use this kind of relative ratio here. So this is a proportion. This is a ratio odds, where I adjust my model schedule. And this is just some of the results. They're coming out again really close to the observed line. The observed data, and the dashed line is predicted. And this is for one county, Adams. And yeah, it's not perfect everywhere, but just look at the periods where they had 10-year chunks of data. So 1940s, 1950s, 1960s, 1970s, and so on. But it's just a different county. Again, it's capturing the different shapes, different levels. So I'm quite encouraged by this simple approach. And it seems to be, at least I'm going to try to sell it, is that a way forward from the traditional trying to model the net age sex patterns. Actually, to make it more complicated, but it helps. So that's all I have. That's current work that I'm working on. If you have any questions, I'd love to hear them. Thank you.